The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to another in our series of webinars from D-Link. Today we're going a little bit outside of the box and we're going to be doing a slightly more technical webinar, which is great news for my colleague Craig, because he gets to do most of the speaking, and it's also great news for me because Craig gets to do most of the speaking. So we're gonna be talking about business continuity and basically related mostly to networks. And you've already heard Craig. He's with me here as always. Hi, Craig.
Hello, everybody.
Still bearing up, working from home. Everything's still going smooth for you there, or?
Still going good. Yeah, not gone too crazy yet. But, it looks like there's light at the end of the tunnel if you watch the news today. So fingers crossed, it's all gonna work out.
I don't know. I'm kind of used to working from home now. I'm kind of get used to it because I've got a good little setup going on here. So anyway, let's get on with today's business continuity. So I'm fairly sure that everyone who's on the webinar today has experienced network failure at least one time while they've been at work, and we all know that when the network goes down, pretty much everything stops. I had a situation in a previous company where when the network went down, they just sent everybody home because there was pretty much nothing that anyone could do. When the downtime, when it lasts just a few hours, there's a different level of impact on different businesses. For instance, if your business is a web-based business, it's going to have a massive impact on you. Just imagine Amazon.co.uk being down for a day and the amount of money they'd lose from that. So it's very important for businesses to design a network that will stay up despite one component in the network failing. Even more so for those that a brief downtime would have a major effect on. But we understand that adding network redundancy will increase cost and complexity to your network. So myself and Craig are here today to talk about the most efficient ways of setting up redundancy and are looking at just how much money that can save you in the long run. So we move on to the first slide. We've got some estimations here in US dollars as to how much unplanned downtime costs. So I think the upper example there, I think that's fair to say, Craig, that figure's probably someone like Amazon being down, where pretty much every part of business they do is online and they have no in-store presence to make up for that money.
Similar, yeah. I mean, a lot of people do host, and there are some hosting companies outside of the big top tier hosting services. So, you can host yourself. There are some people still doing it that prefer to have that kind of complexity and having that kind of infrastructure. But even so, VoIP services, things like that, anything that can be hosted or anything that is a service for somebody has the potential to fail at some point. And that's what we're going to be talking about today, is how we can plan and design our networks so that when it does happen, because let's face it, it's going to happen. This isn't a case of it could never happen, or what do we do if it might happen? It will happen at some point. To somebody. And if we design things in such a way that we can expect that, then it doesn't hurt us so much.
Well, it's quite a scary fact on the slide, isn't it, that 30% of 3 in 10 businesses have no plan whatsoever. And that doesn't include anybody who has half a plan or not a full plan. That is just no plan whatsoever for disaster recovery, which seems slightly crazy.
It does. It's very scary as well. Very scary. It's because I've certainly worked with people in the past. Certainly have had people come up to me once they've learned about disaster recovery and what they've had and how they've gone from the point of starting a business up until that point is quite scary sometimes.
It is indeed. So there's a few examples of various parts that can go wrong, and what you need to do about that on the screen now. We discussed a few of these bits already, but each one of these can have a massive loss on your company. But as the second stat on the list suggests, 45% of unplanned downtime is due to hardware failure, and that's mainly the focus of what we're going to be talking about today, isn't it, Craig?
Yeah, absolutely. Just to point out a couple of things that are on here. It's really, as we said, voice and data impact when a network fails. You've got to remember, this isn't just pieces of hardware. This is people in a building most of the time that won't be able to do their jobs. And so you're paying for this cost as well. You're employing these people in some cases, and if they're just sitting around doing nothing because they're waiting for something to come back up, it's not just money that you're paying them to do nothing. You're also what they're doing or people they're helping. They have to wait as well, and it all has a negative impact, and it gives a very bad experience, especially if you're in that customer-facing service as well.
Sure. So we're going to look at a few sets of concepts now. This is where Craig's really going to come into his own, and I'm just going to sit back and watch and maybe throw a few questions at Craig as he goes along, because this is it's very, very similar to the training course you do, Craig, isn't it? Where you talk about this.
It is, yeah. So throughout the year, what we do is we get people in and play with our switches and equipment that we have. And a lot of people are quite surprised at how you can design a network and bring in that redundant systems when really the equipment is no different to what they've already got, and it's really just about how you plug it in. So that's what we want to try and get that through today, is that if you have installed D-Link before, you might not be using it in quite the way that you thought. Or maybe we can shape things, and if you're not used to D-Link before, then this will give you a little bit of an insight into how our thinking works and how we can implement things.
Sure. I didn't mention at the start, but if anyone's got any questions, there is the question box on the side here. We're going to go through a few topologies now, so there might be maybe a few questions that come up about that, and I might have a few questions for Craig myself. So we'll move on now then.
Yeah, absolutely. So let's have a start with topologies and designs that you might see installed or how they work. Now, normally when people talk about rings on a switching network, the first thing that they say was, oh, that's bad. Yes, it can be bad. If you don't set things up properly and you create a ring on your network, it brings the network down. However, if you go in knowing the functions and doing it right, you can actually increase the amount of redundancy on your network, and you can actually make it a more secure system too. So ring topology. So if we have a look at the ring quickly, what we've done is we've used some cables to connect all the rings together in one circle. And what that means is if any one of those switches goes down, we're still able to send traffic from switch to switch around the other way of the ring. So for example, if we have a look at one switch that's connected directly to another switch, and that link between them goes down, we have to go all the way around the ring to get to that other switch. Now, that's actually a lot of traffic we're passing through the network in order to still do the same function. So the idea of redundancy is not just to allow it to have to keep working in case of a problem. We also want to make sure that the traffic is usable, that it doesn't affect the rest of the network in such a way that it impacts the amount of speed and data retention that we have. So we need to design a system that's fast and efficient, but still has redundancy. Now, if you look on the right-hand side is our star topology. This is a very typical topology in a flat network. But the problem with this one is that we have a core switch that goes down, the rest of the network goes down with it. However, data-wise, we're sending from one switch to another. We're only ever two hops away from getting our traffic to the destination. So the question is, how can we combine what's on the left with the redundancy with the efficiency that's on the right?
I think we know how. Let's have a look.
So that's where meshing comes in and how we build our network. Now, as you can see on the left, we've got a lot of cables. Now, for some people, this might actually be the best way of implementing what they require. So I have implemented this kind of design technologies, and it's mainly for very heavy security systems or something that is really absolutely cannot deal with any downtime at all. And that's why you would have a mesh-to-mesh system. So every device is connected to every other device. Now, while it's heavily redundant and really has all of that optimal data traffic, it's not really convenient for cabling costs. So if we factor in fiber cables these days, and we'll have different kinds of fiber cables where it's multi-mode or single mode, especially the single mode stuff can really run a long distance, but it can be quite expensive. We kind of want to factor that in. It's not easy to run cables either. So if you're not used to running fiber cables, that means getting somebody in and you have to pay them for the installation, plus the point of the cable and the splicing. So it can be costly to run all that cables. So the question is, can you get that kind of cabling or that kind of redundancy without running all of the cables? And that's where the partial mesh comes in. So if you look at the partial mesh, what you actually see is you've got that really optimal redundancy. We've taken a few of the cables away, but we've still got redundancy. We've still got really good data retention in terms of hops and how to get that data across the network. We don't have a single point of failure either. So that's really what we can do as a company with our switches, is we have the technology built into them and that you can implement so that you've got your network, nothing will necessarily need to go down, and you can implement this topology as well as other types as well. So you don't necessarily have to have a full partial mesh. You can have factors of that in your network. You still have a core network, and there's other things that we can chop and change as well. So there's not one design suits everybody, but at points in your network, you can implement some of these features to give you that little bit of redundancy, whether it's at the core edge or that distribution layer.
Yeah, it looks like a good balance, the partial mesh between like a full solution and uh, having a great layer of connectivity there. So yeah, I think
Yeah,
that looks like
yeah.
a good balanced one. Move on now. So spanning tree protocol.
So, like I mentioned, if you was to take things out of a box and plug it all in the way that I've just mentioned, nothing would actually work. And that's because there's a lot of features that actually need to be implemented on the switch. So the switch that you purchase, you need to be aware of what you're actually getting on those switches. If you went for like an unmanaged switch, pretty much everything we're talking about here isn't going to be possible. So it's really going to be that managed solutions we're looking at, or that smart switching area. Definitely smart switches. Everything we're talking about today is going to be available on. So spanning tree protocol is something that you would implement just for a couple of extra links for that, just in case you get that problem. So in this example, let's say we have computers that are connected into our switch at point A. That's going to be sending traffic directly over to point B and to point C as an example. Now, if point A goes down, so let's face it, A to B, that's working. There's a cable connected from A to C, but it's actually dormant at this stage. So there's no traffic designed to pass over that unless it goes from A to C directly. Now let's see what happens if the link goes down with spanning tree protocol. And you can see our link has gone down between A and B, and A to C has actually now kicked in, and we're able to still send to B in that traffic area. Okay, so that's the whole point of spanning tree protocol. We're implementing those additional links from device to device. It doesn't bring our network down because every device that we have set up, or every switch that we have set up, has spanning tree enabled, and we're able to send that data from one to another. And it's always got that dormant link ready to come up. Now, a different type of connectivity is link aggregation. Now, what link aggregation does is it's more about switch to switch, or we'll go into stacking in a moment, maybe a physical stack to another physical stack. So in this example, we've got a 1 gigabit link, and that goes from switch 1 to switch 2. Now, by introducing a second link to the same switches, we're actually able to double up on the bandwidth. So we now have a 2 gigabit link because it's a 2 gigabit cable. So we've got gigabit copper ports that are connecting these up. 2 cables means 2 gigabit link. So it would be a standard Cat5 cable. Now, with link aggregation, we're actually able to implement even more. So we can have a link up to 8 of these devices, so 8 of these cables, which makes for an 8 gigabit connection, which is really great if you've got some really heavy, intense users on your network, or maybe you've got a lot of devices going on, or maybe you're running fiber cables. In this example, I've shown some copper cables, but you can do the same thing with the fiber uplinks as well. So don't think that you can't, you definitely can. So you could have a 2 gigabit fiber uplink, just sacrificing 4 ports in total across the 2 switches, and then you'd be able to still uplink to other devices, and you'd be able to start generating these really, really big links between each other. So what you actually get is you're increasing the amount, cheap cabling options, but you're increasing the amount of bandwidth you've got, and it means that if you're at maybe like an older network, you're able to extend the life of it just that little bit more.
So would 8 be the maximum on all switches, Craig, or the theoretical maximum, or is there any reason?
Not all switches. I've actually put 8 as a minimum for D-Link switches there, Alan. So I didn't want people to think that they can get 16 cables on every of our switches. Some of them can. Some of our higher managed ones can go even more than 8. But the standard for our smart switches is 8.
Would it work with 10 gig links as well in the same fashion, or?
Yeah. So let's say, for example, we had our DGS 1510 series here, and you were using fiber cable connections. You could potentially do all 4 of those ports on each of them, which means 8 ports in total, to give you that 40 gig link between them.
That's some nice speed.
That's a nice speed. Obviously, you'd sacrifice your uplinks, and then your uplinks would be on the copper itself. So you wouldn't really do that in a real working world. But definitely you might do 2 of them. And that's something that we do every day, actually, at D-Link, is 20 gig links across these devices rather than 10 gig link. And then you can start using your other ports for other things as well.
Excellent. Stacking.
So stacking, yes. So stacking is something slightly different. It's only on our 10 gig products. And what that basically means is you're able to connect devices, the switches themselves, and turn them into different ones. Now, normally what you would do in an environment is you'd start creating these links from switch to switch. So you have one switch, you add a second switch, you add a third switch. Every time you're doing this, you're actually setting up these switches completely independent of each other. And it starts to get really messy. The problem with this is that it's a lot of management that's required from you. If you're in an area where there's a lot of devices that need connectivity, you might have 3 or 4 switches in the same room, which might do, let's say for a school, for example, you might have an art block or something like that, or maybe a 6th form block. So you'll have these switches in the same room anyway, but you still have to manage them independent of each other. So let's see how we can cable up with stacking and how that changes things works. So as we mentioned, we might be in the same room area, or the switches are in the same block, and we start adding our switches and the same stack. Now what that means is all of these devices that we then cable together are going to have one IP address. So management-wise, it's far, far easier. You'll start cabling them from one to the other still. So you'll have a 10 gig link, and those will be using our direct attach cables. So you have a direct attach cable, which is a fiber transceiver connection, cabling them all up. And then what you actually do is you finish the loop by going from the last switch back to the first. And then you can have different stacks as well. So you've got all of your cabling, all of redundancy. If any one of those devices goes down, it doesn't affect the rest of your stack. And the reason it doesn't affect the rest of your stack is because they've all got the same configuration, and if a switch goes down, it goes the other way. So it doesn't have to go. So let's say in our example, we've got 3 stacks now. These 3 IP addresses. 3 IP addresses to manage all of your network in such a big network environment as well, which makes management very easy. Now, if we start linking these stacks together, typically what you'd do is you'd run a fiber cable connection. So we've got redundancy per stack, but we haven't quite factored in redundancy for our network at this point. So now if we take in what we learned from link aggregation, we can add more cables and increase the amount of throughput that we get per stack and the amount of redundancy we get through it too. Any one of these stacks goes down, you can still get to them. Now, we can slightly cable them differently as well. We don't have to do it quite the way I've done it. Let's say the first stack on the left could have a cable that runs to the stack on the right. And then the stack on the left can also have a cable that goes to the second stack as well. So we can manage it so that if the stack goes down, you can still get to another stack as well. And that's how we factor in redundancy here on our switches. So in a real working environment, how would we actually do it? So we'd have like a financial and a sales block, and those would have lots of people perhaps on those floors. So more than one switch is what we need. So that then we'd factor in stacking across those devices. So three switches on one department, 3 switches on another. We stack them together. If any one of those switches goes down, we're still able to get to the rest of our network. Yes, it means that perhaps there are some devices that goes down. You can't factor in everything because obviously devices have to be plugged in. What it does means is if you've got any port spare on another switch, you just move your cables up and then you can work out about getting that other switch operational, whether you've got to RMA it or return it or purchase another one, however you want to do it. But it does mean that you've still got that functionality on your network. Then we use our link aggregation. So link aggregation also has a redundancy there, not just for throughput, because if one of your links goes down, you've still got another link to rely on as well. We factor that back into our core, so we might be running some 10 gig fiber cable connections, which means we've actually got a 20 gig link back to our core. And then we've also got the rest of our network in terms of the data center. So in this case, we've got a 40 gig link that's going to another system, which is our core area or top of the rack for our data centers. This is kind of like a larger end of the scale, but you can start to see how that redundancy is kicking in and nothing can go down at this point other than the core. So really what we're looking at is the core area now. Where can we sort of think about redundancy there? And we've got some solutions for that too.
Sure. I think this is a good example as well, Craig, with the separate teams, finance and sales in this example having different access and different networks, because obviously with GDPR and all things like that, different departments need different access to different levels of data and stuff like that.
They do, yes, but because it's a managed network, Alan,
Yeah.
if there are people in sales that do need to have the same services as finance, they still will be able to get to those devices by going to the core and back, which is why you'd have a bigger core.
Sure.
But logically, if you put them on a different VLAN, it's up to you how you manage it, really, at the end of the day. But that, yes, you're absolutely right. If you wanted that to be completely separate from others, certainly put them onto a different VLAN. We'll keep them clear of that.
Well, with a lot of people working from home at the moment, I think that's even more of a consideration, isn't it? So the access that people are given. So yeah. Right.
Yeah, absolutely. I mean, a lot of people are using VPNs to get to their network, so you do have to think about network security from that angle as well. Absolutely.
And you can also watch our bite size on how to set up a VPN as well. So that's
that was a good segue. That was a very good segue.
That's why I'm in marketing.
Okay, so to accomplish physical stacking, we use a different style of cable. You don't necessarily have to use these, because what these cables are is 2 transceivers, 10 gig transceivers with a molded fiber cable. Now, if you want to use 2 10 gig transceivers with your own fiber cable, that's certainly possible as well. But to keep it nice and neat, keep it easy to use, we do recommend using the DAC cables. And what that means is that you can just click from one to another. So in our example, we have different types of 1510 switches. So some of them are sort of 48 gig copper with some uplinks. Some of them 24 gig copper with some uplinks as well. And how you would do it is that ring system. So we're actually called ring stacking in this, and that gives us our redundancy. Now, I did mention before on the previous slide that redundancy of the core is also something that we can do as well. So we call this VRRP, and it's going to be on some of our higher managed products. What that means is that you can actually have one of your core networks. So you'd have 2 core switches, and your core switch, one would be active and the other one would be dormant. However, they're all plugged into the rest of the network, so the cabling is still there as well. Now, if you look at this is kind of our high level really redundant system, ultimate kind of redundancy. Might not necessarily be for you. There's certainly some aspects of it that could definitely be used for you at the whatever area that you're in, or whatever design pattern you're looking for. So you can certainly chop and change some of these for your networks. So VRRP, like I said, active and dormant at that core, and then we have our aggregated links going back to our switches, and then every switch will also have, say, spanning tree protocols implemented, so that access layer can talk to the aggregation layer, or even maybe we could use some LACP, but in this case we're just going to use that as spanning tree. So we're now taking the features of the switch and implementing in a slightly different way to think about how we can implement it from a cabling perspective, but also how we can do it in such a way that doesn't bring the rest of our network down, that gives us our redundancy, that gives us our data retention, and how we can optimize traffic on our network.
I think it's important to mention whenever this slide comes up that Craig is available to help you out with any of your needs for network design. This is kind of like the coup de grace, as complicated as it gets. Obviously, there could be a lot more switches involved in this, but we have the tools, and Craig obviously has the expertise. So if anyone out there has the customers, come to us, drop us an email, give us a call, and we can help you out with all of these kind of network designs.
Yeah, and just to touch on that, Alan, I've certainly helped quite a few people over the years who have also been installing D-Link for longer than even I've been working at the company. And you'd be surprised at how many people have purchased these switches and don't really look at the features or understand the features that they've purchased. And they kind of they build these flat networks because it's what they know. So if you can try and open your mind to some of these other features that are already there, do a little bit of investigation. Certainly if you have any questions or on any of the topics we discussed today, just ping me an email and I'll have a look at it. And if you ever have some sort of project that you're working on and you might need a little bit of advice, we here at D-Link, we're always there to give you a little bit of advice on what we can do for you and how it can be implemented. Yeah, absolutely.
Yeah, and I've been on the switch training course with Craig twice now, and everyone who leaves the course always says that they have learned something, even those who've been in the industry for a while, even some of those who maybe didn't expect to learn anything have all gone away and learned something. I think the only person who hasn't learned much is me, but
just because you're on your laptop instead.
Have a day job, unfortunately. But I do enjoy the tea and biscuits while we're there. Pardon me.
Yes, so on to our kind of final topic. So what I've mentioned is what happens when things can go wrong, or how we design things so that in case something does go wrong. But there's also a topic we haven't talked about, is implementing systems onto the actual switches themselves, so that we don't necessarily have to have something go wrong, or maybe we can prolong it. So a lot of our switches, especially our top tier managed ones, will have fans that can chop and change, and you can change whether it's a module bay that you want or whether it's an additional fan system to keep it cool. We have redundant power supplies that we can put in, so that if one power supply goes, your network is still operational and running. Safeguard engine is something that comes onto our switches. Now, Safeguard engine, I think, is probably one of our features that we talk about least, and it probably does more than people realize. If you've got someone that's on your network and they've got a PC, for example, that might have been compromised, they'll be sending lots of traffic on your network through the switch. Now, the switch can sometimes have a look at the data network and realize, okay, this is a lot of packets that are coming in from that one person on the switch. Maybe what I'll do is I'll kind of flag that or report that via SNMP, or maybe just shut things down so that that person doesn't affect the rest of the network. That's the Safeguard engine in a nutshell. There's more to it than that, but it's something that comes on our D-Link switches. 6 kilovolt surge protection. So if you're someone that's installing cameras and things outside, the switches themselves can handle quite a pack of charge coming back to the switch. So what will happen is the switch can protect itself from that kind of electronic shock coming to it. And then we have our reporting features to let us know how our network's working and other things as well.
And anyone who has to go to the dental hygienist can definitely agree with the prevention is better than the cure. But I can vouch for that. It's quite a painful experience sometimes. Take better care of your teeth, people. So now we're going to move on to wireless redundancy.
Yep. So let me just bring that back up. So wireless redundancy. What is wireless redundancy? I get people asking me when I mention that a lot. They're like, how do you do wireless redundancy? That doesn't even make sense. What you have to do is you have to think about wireless redundancy before you go into an installation in most cases. So you have to be aware of it, that it exists. But you can, if you have an already built-in installation, you can change the settings on what you've already got and factor in wireless at a later stage too. So how we would do it instead, when an access point comes out of the box, it normally comes at about 100% power output. So the most it can do at any given time. With wireless redundancy, what we want to do is we actually want to lower the power output. So we lower the power to say 50%. We factor in an additional access point. So it does mean that you're probably going to be putting in more access points than perhaps you would if you just wanted a full broadcast range. So you lower it to 50%, factor into more access points. That way, if one of the access point does go off, we have two other access points that are now able to increase the range of power they output, and they overlap so that they cover that area. Now, it does mean that you still have an access point that you have to factor, whether you want to replace it or find out what's happening with the access point. But it means that people in that area have wireless network connectivity. So if you're in an environment where you absolutely have to have your Wi-Fi working because it's detrimental to your company, then wireless redundancy is the way forward for you as well.
Well, it's the case for hotels and all sorts of things like that, isn't it, Craig? Where if one access point goes down, you can generally connect to another one.
Absolutely. I mean, if you're looking at theatre halls or lecture halls and things like that, where you've got some high density areas as well, then wireless redundancy is something you definitely want to implement. Yeah,
so it might be a slightly weaker signal, but at least you can carry on. Yeah.
Yeah.
Would you need a wireless controller for this kind of stuff, Craig, or?
You would need a wireless controller because the reason for that is the access points have to know when to increase their power and why they have to increase their power as well. So a wireless controller is absolutely fundamental to this point.
Sure.
Yes. So product range, brings us on to Nucleus, as we generally tend to go towards. So Nucleus Connect is our software management system. So it's a piece of software that you can actually run on your PC, and it will handle all of these access points. So any of these types of range, whether it's something that you want indoor, outdoor, small range, big range, they all can do that same thing in terms of that self-healing wireless connectivity as well.
Yeah, it's quite a range on there. Range for every solution there. So.
Yeah, absolutely, and you don't have to stick with one, of course. When you're doing a network, you would choose different access points, put them into different areas. So, for example, you might have a warehouse, but then you might have an office connected to that warehouse. So maybe you'd use one of the rugged ones, and then maybe you'd use one of the more access points that's kind of catered to that office environment. And then think about indoor, outdoor access points as well. So there's a lot of range in any kind of given scenario we can cover. And that brings us on to our Nucleus Connect Hub. So I mentioned there's a piece of software. Now the software itself can actually run 1,000 access points, all dependent upon what kind of machine you use. However, that's plugging it onto a PC. Now the Nucleus Connect Hub runs the same software, but it's a small box that you can rack mount if you want to. And what that means is that it's also going to be running all the time. It's not going to interfere with any services. So for example, you have a PC and Windows Update, or you're doing other things with that server. It's not going to affect your wireless environment. It's going to be a standalone system that runs the software, single sign-on back to our cloud. So there's got some additional support there too. And it will run 100 access points without having to think about additional licenses or anything like that, and that will perform your self-healing ring as well.
Yeah, there's a lot of advantages to something like the hub, isn't there? It's absolutely dedicated to your network. You're not going to get that awful blue screen of death that takes everything down. And I think
Absolutely, yeah.
it can be it's an easier deployment, isn't it, Craig? Because it doesn't need to be manually checked or managed. You can just leave it in a more remote location, which makes
That's right. You can plug it in, you can set up your network, and then you can forget all about it as well, which is nice.
just manage it from the app. That's what we do now. Okay, so the last topic for today is 4G failover, and we got a quick estimation on this last slide about the number of lost hours. UK businesses suffered 149 million hours, which is an astronomical figure. And the estimation of 12.3 billion in lost productivity. I mean, it pales in comparison to what's going on now, I think, but it's a massive consideration for business. And one of the solutions that we have for a backup is the 4G network. So the 4G routers from D-Link are built with the failover, business failover built into them. So if your main internet connection goes down, you would connect the router to your modem, Craig, and then
so generally, like you said, you'd have your normal internet connection where it's ADSL or VDSL, and that would click into a port, which is your WAN port. That's just standard for a router. But what they'll also have is a built-in 4G SIM card slot. So if that WAN port goes down or it can't get connectivity to the internet, then it kicks over to your 4G SIM card to keep your internet up and running so that you can send your emails and things like that.
So a very cost-effective solution, and you can get some fairly good speeds here, and you can get multiple people connected to the 4G router. So it's a great solution, especially for a small business where, like I mentioned before, my previous company, when the internet went down, we all went home. If we had one of these 4G router backup solutions, the failover solution, then we could have stayed in the office and carried on with essential tasks such as email and even power the phones. That could have carried on, but instead we all enjoyed an afternoon off. So everything has a silver lining.
Good for you, not so good for the business.
Yeah, exactly. Okay, so that's it for today's webinar. There's a few questions in the question box, so we're going to be testing Craig's grey matter now.
Oh, okay, brilliant.
Okay. So the first question, they're coming in order, so we've got to go right back to the start of the presentation. I think we probably know this one from how we taught, but which topology solution would you recommend, Craig? As it's which would be the best blend for you between the cost and the security that the network would provide?
Well, okay, so it's really going to be down to the network environment that you have and what your needs are and what's required. So, for example, most companies will have the standard access layer, and that's where all the devices get plugged into, and they'll also have a core. Now, you might be a bigger company or a bigger installation that you're doing where they need that distribution platform so that it can handle all the traffic and then go back to the core. And maybe on that sort of access layer edge part, you might think about just a couple of extra cables. Now, whether the switches run between each other before going back to the distribution, or maybe they just have additional cables going back to the distribution, that's a possibility as well. So you've got the choice of going spanning tree to get that little ring going, or maybe just link aggregation, and you're just worried about the cable, two cables instead of one cable, and handling it that way. So going for those, it's really the whole point of this webinar today was to let you know that it's not a one-size-fits-all solution that you need to even think about.
Yeah.
It's going to be purely project-based, and every project that you get is going to be slightly different from the last one. So if you know what you can do and what is available to you, then you can handle any project that comes your way.
Excellent. Link aggregation. Can you use link aggregation between different vendors? It's coming.
You can. It's a standard. Link aggregation is a standard. It's top of my head. I think it's the 802.3 AD standard, which means that as long as you've got a switch that conforms to the standard, you'll be able to link them. So if you've got a D-Link switch linking to another switch that's got that standard, yes, it should be able to work.
Yeah, but we don't recommend that. Just stick to D-Link.
No, we recommend you buy D-Link.
One question on stacking, Craig. Is there a maximum to the number of switches in a stack?
Yes, there are, and it's going to be very dependent on the series that you buy as well. Now, in my example, I think I use a 1510 as an example, which is about 6 or 7. I'll have to check on that, 6 or 7 switches that you can have. Some of our newer switches have an additional constraint called stacking cost, which is slightly different. So let's say stacking cost for one of a 24-port switch might be a cost of 1, and a 48-port switch might be a cost of 2, and then they might have it up to a total of 12 as an example. So however you get there, whether it's you've got 6 devices of 48 ports, or maybe a few of different ones, whatever comes first, whether it's 9 switches or a stacking cost of 12, there's some differences. So you do have to be aware of that and what switching series you're going with. So it's all on the data sheets. If you need some help or advice, then contact us first, and we can just tell you exactly how many switches you can stack with it.
Well, that leads me very well into the outro. We almost sounded professional then, Craig. So just coming up on the end now. So just to let you guys know that Craig and myself will be back in a couple of weeks' time. We've got a great presentation prepared for a couple of weeks' time, because we're going to be talking about all of the new products that we've got in our smart home range. We did talk briefly about Wi-Fi 6 a few weeks ago, but now we've got more information on the products that are going to be coming soon. We've got new cameras. We've got new other stuff coming. That'll be in a couple of weeks' time. So make sure to sign up for that webinar. I think it's on the 19th off the top of my head. And then after that, we've got a very requested one where Craig's going to talk us through how to use the Wi-Fi planner. And then at the end of June, I think the next one is 5G, which is well looked forward to and should be full of great information for you guys. In the meanwhile, if you've got any questions that you didn't get to ask on today's webinar, just send us an email. The email address is at the bottom there, uki-sales@dlink.com. Drop us a line on 0208 955 9000. We are all working from home, but the people have taken the VoIP phone homes with them, so the landline numbers are still working. Don't be afraid to get into contact with us with any questions. As we said before, we mentioned training during this. If anybody wants to learn any more about these protocols, we will be doing training as soon as this is over and it's safe to do so again. We may have to obviously limit the numbers of people that we have in a room at a time. We really don't know where we are with that, but we are obviously working to get back to some sense of normality, which we hope to be able to bring you soon. Okay, so thanks a lot for joining us today, everyone out there. Stay safe, and myself and Craig will see you again in a couple of weeks.
Yeah, thanks for listening.
Thanks then.